on Chapter 6, Lesson 7, Equivalent Expressions. Please turn with me to page 495. Let's look at the vocabulary. Okay, so we have some very important vocabulary. We have the word term. So the word term, each part of an expression is divided into terms and separated by operators. So your operators are add, subtract, multiply, and divide. So in this case, we have three terms, 3x, the 7, and the x. So let's look at this problem down here. Let's get rid of the blue box. In this case, we have 1, 2, 3 terms. Can't spell terms. Let's try that again. 3 T-E-R-M-S, terms. Okay, then we have a coefficient. A coefficient is attached to the variable by either multiplication or division. So x over 2 or 2x. The 2's are called the coefficient. So in this case, the 4 here and the 2 here are called your coefficient. And then the constants are the solo are numbers that have nothing around them. So the number 9 down here we call a constant. A 9 is a 9 is a 9. Will always be a 9. Now let's go back to the top one. We have 3x plus 7 plus x. This x here represents 1x. If it helps you to put a 1 in front of it, please do so. So we have 3x plus 1x, which would end up being 4x plus 7. The 7 is not an x, so I can't do anything with that. So let's look at this. And if I make them into animals, it's easier to understand. I have 4 newts plus 2 newts for a total of 6 newts plus 9. Is there an n after the 9? No. Therefore, I cannot combine it because it's not a variable. So again, when you divide these, or when you simplify these, look for like terms. Okay, let's look at the real world example. Andrew's mother gave him a computer game and $10 for his birthday. His aunt gave him 2 computer games and $5. The expression x plus 10 plus 2x plus 5, where x represents the cost of each game. What is the coefficient of the term 2x? What's hanging out in front of the x? You guessed it, a 2. How many terms are in this expression? Well, currently there are 4, but I can simplify this guy. The 1x plus the 2x makes 3x, and then 10 plus 5 is 15. So now I have 2 terms. All right, turn the page. So just as you would simplify a numerical expression, 3 plus 3, which is 6, you would do the same thing with a variable. So x plus x, there's a 1x and another x. Combined makes 2 x's. So when we have an expression like 4 in parentheses 6x, let's break it apart. That's 4 times 6 times x. When we look at this, we first see what we can do numerically. Is there anything we can simplify numerically? I look at this and I say, well, I have a 4 times 6, which makes 24 times x. And again, I want it in the form of coefficient variable, so I'm going to get rid of that dot and just call it 24x, because the dot we call the invisible operation, which in algebra we do not show. So 24 times x becomes 24x. Alright, now it's your turn. Simplify these expressions. Pause the video. Did you get what I got? I got 33x, 3x, and 8x plus 8. Let's look at A. Using the commutative property of multiplication, I can switch the x and the 11. And so then I have 3 times 11, which is 33. And I don't know what x is, so then all I can do is leave it as 33x. In B, each one of those x's represents 1x. So 1x plus 1x plus 1x is 3x. And then the last one, I have 2 variables and 1 constant. So the 7x plus the 1x makes 8x plus 8. And I'm done. In this case, I can't do anything else with this. Why? Because that's 8x and the other is just simply an 8. So I cannot combine them and there is no answer. When you see these problems, they're going to say simplify. They are not going to say solve. You cannot solve these unless you know what x is. Alright, keep going. In a word problem, you have to see what's going on. So we have 3 friends who pay X dollars each for admission to the museum plus $1 to see the mummy exhibit. I'm going to change this X to an A because that makes more sense. That's an admission ticket. And then $1 each to see the mummy. The 4th friend will pay admission but will not view the mummies. I guess he's a scaredy cat. So in this case, we know that we have 3 friends that are going to get an admission plus the mummy ticket, plus another person who's going to buy an admission ticket. So again, I do the owl. 3 times A is 3A, plus 3 times 1 is 3, and then I have my A left over. So I again look to combine like terms. I have 3A plus 1A, which is 4 admission tickets plus $3 for the mummy tickets. So again, put a $sign in front of both, and my simplified expression is 4A plus 3. I can't solve this. I don't know how much an admission ticket is. It could be $10, it could be $2, it could be $5. I don't know. So I can't do anything else. All right, your turn. Pause the video. Alright, in this case, I have 6 friends going to the museum, but only 4 doing the mummy exhibit. So I don't really need to do the distributed property because I know I'm buying 6 admission tickets, which is the 6A. And then 4 people are going to see the mummy. 4 people, and those are at $1 a pop, so that's 6A plus $4. And again, they're both going to be money in the end. And I don't know how much the admission ticket is, so I can't do anything else. Turn the page. Alright, simplifying expressions with 2 variables. When we have 2 variables, we have to treat them independently. We have 2 x's and we have a y. So in this case, I'm going to put little squiggly lines under my x's, and I'm going to put a little caret on top of my y. If I made these k's, I could make a story out of this. I have a kangaroo and then another kangaroo joins the party for a total of 2 kangaroos, plus a yellow jacket. So again, when you think about these in terms of animals or articles, it's easy to get the answer because you can just think about combining things that make sense that they go together. So number 3, we have 14y plus x plus 22y. Well, in this case, I'm going to have to do the commutative property and the associative property, or what I do is just put little squiggles. I'm going to put squiggles on the guys that belong together and a caret on the guy that doesn't. So in this case, again, I'm going to make him a kangaroo. I've got 14 yellow jackets and 22 more yellow jackets. When I add 14 and 22, I get 36, and they are angry yellow jackets. And then I got Mr. Kangaroo, who's probably going to run away as fast as he can. Now again, my answer is just a little bit different because I used a K instead of an X. In number 4, I have to do the distributed property. So again, I'm going to draw my owl. I got 4 times 2x. So 4 times 2 times x. I can do the 4 times the 2, which is my 8. and those are x's. Then I've got 4 times y, which is 4y. So in the end, I have 8x plus 4y. I can't do anything else with this because I've got x's and I've got y's. I don't know what the value is of either one, so I can't simplify further, and I certainly can't solve because I don't know what each of these variables are worth. The last example, number 5, involves the upside down division tree. So we put 27x plus 18y. So the first thing I got to do is think about 27 and 18. Where do I see them on the multiplication table? I could think 3, but I can actually think higher. I know that 9 is the greatest common factor, so I'm going to pull out a 9 on both of them. Then I'm going to set up my parentheses. 9 goes into 27 3 times, and those are x's. I'm going to bring down my plus. 9 goes into 18 2 times, and those are y. So in the end, I've got 9 on the outside and 3x plus 2y on the inside. So now it's your turn to do E, F, and G. Again, number E, you're combining like terms. In number F, you're doing the distributive property. And number F, you're going to do the upside down division tree. Good luck. Pause the video. Did you get what I got? I could combine the x's to get 5x plus 9y. The next one, the distribution, 7 times 3 is 21. Those are x's, so 21x plus 7 times y is 7y, so it's 21x plus 7y. And then the last one, I can pull out a 4, which leaves me a 3x plus 2y on the inside. So again, it's 4 in parentheses, 3x plus 2y. Turn the page. All right, in the word problem, we have a farmer's market selling fruit baskets. Each basket has 3 apples and 1 pear. Use A to represent the apple and P for the pear. Write and simplify an expression that represents the total cost of 5 baskets. So we have 5 on the outside, and the inside we have 3A plus 1P, 3 apples and a pear. And we have 5 baskets each. So again, we do the owl. 5 times 3 is 15, and they're apples, plus 5 times P is 5P. So in the basket, we know we have 15 apples and 5 pears. All right, get the guide to practice done. See you soon. Pause the video. Okay, check your answers. Did you get what I got? 30x, 9x plus 5y, 8x plus 20y. For number 4, when you factor, you pull out a 7. So 7 in parentheses, 5x plus 4y. In number 5, we got 5 skirts at x and 3 tops at 9, which is 5x plus 27. The next one, we have 5 polishes and 2 lip glosses, and we're buying 8 gift bags. So 8 times 5 is 40, that's polishes, plus 8 times 2 is 16, and those are lip glosses. So again, how does this help you? It allows you, the properties help you to move terms around so that you can simplify equations. The whole point of getting these is to get them into their lowest form so that when you do understand or you do get a value for the letter, you can then go about solving it. Thank you. And we're going to do everything but shut this down. Okay, you're going to have to hold on while I get this closed so I can close down my video. You're probably wondering what's going on. I am too. So I'm going to try to close this video down. And thank you. Have a great day.